Welcome to the Ota-Lab introduction. In this short presentation video, we will introduce the research direction of our lab, and some typical research topics, and our final goal. Our lab conducts various research activities, based on the knowledge of robotics, and control, optimization theory. Specifically, our lab's research can be categorized into three main directions. First, multi-agent system and robotic system design. In this research direction, we solve various design optimization problems with multiple AGVs or industrial robotic systems. Second, human interactive robotic system and industrial manufacturing. In this research direction, we develop robotic systems for interacting with humans and their application to industrial scenarios. Finally, human analysis and embodied brain system science. In this research direction, we analyze human neural motor mechanism using the knowledge of robotics. From here, we will introduce some typical research topics in each research direction. First, we will introduce the researches on multi-agent system robotic system design. This study proposes a motion planning method based on stepwise large-scale multi-agent task planning using neighborhood search. By introducing human-supportive robots into production lines, it is possible to reduce human fatigue. However, production efficiency must also be maintained. To address this, we propose a novel task allocation and scheduling method that balances human fatigue and production efficiency. Additionally, we address task allocation and motion planning problems for a fleet of AGVs, automated guided vehicles. Specifically, we simultaneously determine which AGV delivers which item to which location and the actual paths for item delivery. In the video, each moving square represents one AGV. Next, we will introduce the researches on human interactive robotic system and industrial manufacturing. Currently, automation of bin picking in factories is progressing rapidly. However, for deformable objects such as wire harnesses, practical implementation remains challenging. To address this issue, we propose a motion teaching system that enables robots to learn grasping positions and postures from human demonstrations. By capturing the positions and postures used by human workers during grasping, the robot can be trained to replicate similar behaviors, even in situations where the target object shape is uncertain. Time and motion analysis of manual operations performed by workers can contribute to improving work efficiency. However, traditional manual analysis is time-consuming and labor-intensive. To solve this problem, we are developing an algorithm that automatically estimates the timing and type of work being performed using machine learning techniques. Our method leverages human skeleton data and object interaction information to recognize industrial tasks in real time. An example of human-assistive robotics can be seen in our nursing skill training system using robot interaction. Targeting the patient transfer motion, which is a representative nursing skill, we model the relationship between the forces applied by nurses and the resulting patient motion. Through a collaborative robot, we build an educational system that enables nursing students to experience and learn realistic human-robot interaction during patient transfers. In maintenance activities for automated manufacturing lines, it is effective to reuse knowledge analyzed during the design phase. However, reusing knowledge across different manufacturing lines has been difficult. To overcome this, we develop a system that extracts conceptual elements from descriptions and constructs a knowledge graph representing relationships among them. Using this graph, the system can infer failure causes, enabling knowledge reuse across different lines. Finally, we will introduce our research on human analysis and embodied brain system science. When designing hand rehabilitation devices, it is important to consider physical differences among patients and provide rehabilitation tailored to each individual's needs. We are developing a cable-driven soft glove that can be adjusted to fit each patient's physique and customized for individual finger movements. To perform effective rehabilitation, understanding the human posture control mechanism is essential. For this purpose, we conduct musculoskeletal simulations. Our research includes the proposal of various controller models, including those for stepping motion, the identification of model parameters that reflect individual patient characteristics, and the analysis of the relationship between those parameters and clinical scales. Through these various research activities, we try to establish design methodology of multi-agent systems including artificial agents, humans, and working environments by clarifying the underlying structure and function in the intelligence and mobiligence of these agents. That's all our introduction video. If you are interested in our research activities, please feel free to contact us. We are also welcome for your lab visits. Thank you for watching our introduction video. We look forward to studying with you.